For perfect problem 5 for Math 111. Basically, I give you some information about a polynomial, a fifth degree polynomial, calling it f of x apparently. And I ask you to sketch a graph of it. So give me a picture of this thing. Okay, well if we're going to sketch a graph, we better know what the polynomial is. We're given some information here. We're told that it bounces off the x-axis at x equals 1 and x equals r. R is something we don't know. And it passes through the x-axis at x equals -2. Okay, so from that first statement, what you know is that we have x-intercepts at 1 and -2, and then also at r. Furthermore, since it's a fifth degree polynomial, we know that the degree of the root at x equals 1 and x equals r is both 2. Because the sum of the degrees of the roots has to be 5, and the degree of these two roots has to be some even number, some positive even number, because of the behavior that the graph has. Anytime you bounce off, you have an even degree. So what I'm saying is f of x looks like some number, I don't know, k maybe, times x minus 1 squared times x minus r squared times x plus 2. And again, where those all came from, x minus 1 because 1 is a root, x minus r because r is a root, aka an x-intercept, and x plus 2 because x minus -2 is what I wrote here, since -2 is a root. And then as far as the exponents, I know that this is an even number, this is an even number, and this is an odd number, but because those three things have to sum to 5, those numbers must be 2, 2, and 1. Okay, so all this information comes from that first sentence. Then I'm also told that it has a y-intercept of -36. So what that tells me is that if I put 0 into this machine, -36 must come out. And finally, it tells me that it passes through the point -1, -32. So that's telling me that when I put -1 into this machine, -32 comes out. And apparently, implied within this problem is that by given this information right here, I know everything that I need to know about this polynomial. So it gives you a little bit of a hint. It says figure out what k and r are by using this information here. So the way I can do that is, well, I guess I could use either of these two statements. I'm going to use the first one first. I'm going to say f of 0 equals -36. So when I change all the x's into -36, all the x's into zeros, I better get -36. So what would you get if you changed all the x's into zeros? Well, I'd have k here. 0 minus 1 is -1. Oh, but that gets squared. 0 minus r is -r. That also gets squared. And 0 plus 2 is 2. So what I get if you kind of clean things up here a little bit is -36 is equal to -2 kr squared. Where'd those all come from? -1 squared is just +1. You can ignore that. Oh, that's wrong. That's why. Try that again. -1 squared is +1. -r squared I can think of as -1 times r, all being squared. And I can take that squared and distribute it in some sense down to each of these two factors. So -1 squared is +1, r squared is r squared. And get kr squared. And then I still have this 2 here. So what I end up with is this thing right here. Problem here is that I have two variables, a k and an r. So I mean, sure, you could solve for one, but it's going to be in terms of the other one. You can't get numbers for your answers. Okay, however, so this is using this statement. I haven't used this statement yet. And this statement says that if you change all your x's into -1, you should get -32. So if I take this original equation, function, and change the f of x into a -32 and all the x's into -1s, I will get a k times -1 minus 1 more is -2. That's getting squared. -1 minus r is getting squared. And -1 plus 2 is just +1. So I get this mess. And if I clean this mess up a little bit, let's see, this is +4, this is 1. So I get -32 is equal to 4 times k times -1 minus r squared. And so now I have these two equations here, and since I have two equations and two unknowns, I can solve. Let's see, there's a couple different ways you can do this. What would be easiest? I think what I'm going to do is I'm going to solve for k and plug that in. The reason I'm going to solve for k instead of r is because with these squareds in here, specifically this squared, if I expand this whole thing out, I'll get r's and r squareds, and it'll just get kind of messy. I think it'll be easier to solve for k. So the way I'm going to solve for k is if I divide both sides of this equation by 2r squared, I get that k is equal to negative 18 divided by r squared. Negative 36 divided by 2 is negative 18, and the r squared. So k is equal to this right here, so I can take that and plug it in over here to get that negative 32 must be equal to 4 times k, how about 4 times k, which is negative 18 divided by r squared, times negative 1 minus r squared. It's a mess. Okay, let's clean this up a little bit. Negative 32 is, well, how should I do this? Sure, why not? Okay, so what I'm going to do is note that I'm going to divide both sides of the equation by 4 to get rid of this, make things a little bit easier. So negative 32 is negative 8 times 4. So if I divide both sides by 4, I get negative 8 is equal to negative 18 divided by r squared times negative 1 minus r squared. Whoops. And then I don't like having this fraction here, so I'm going to multiply both sides by r squared and get negative 8 r squared is equal to negative 18 negative 1 minus r squared. Note that I can only do that if I am sure that r is not 0. However, I do know that r is some unknown number less than negative 1, so it's not 0, so alright, I'm good. Okay, I'd like to make the numbers a little bit smaller, so what I'm going to do is divide both sides by negative 2 and get that 4r squared is equal to 9 times this thing. Negative 1 minus r squared, if I expand that all out, FOIL, negative 1 times negative 1 is positive 1, negative 1 times negative r is positive r, but I do that twice, so I get 2r. And negative r squared is negative r times negative r, which is positive r squared. Okay, so to solve this, this looks like this might be a quadratic equation. I might be able to solve it. I'd like to be able to move pieces around, but the parentheses are getting in the way. So let's distribute the 9 and get 4r squared is equal to 9 plus 18r plus 9r squared. When you try to solve quadratic equations, it's useful to have your well, it helps if this thing factors, which I hope it will. I'll need to set this thing equal to 0 to try to factor it. So if I subtract 4r squared from both sides of the equation, I would have 5r squared plus 18r plus 9 equals 0. So I kind of took this stuff and wrote it on this side of the equation, except reordered it so it looked a little bit more familiar, and that got me to here. Got a quadratic equation. I can solve a quadratic equation. I can solve this a few different ways. You could use the quadratic equation. You could complete the square, or you could try to factor. I believe this thing's going to factor because I wrote the problem so that it will factor. So maybe from here, I'll jump up. And let's see, one method of factoring is to try to find two numbers that multiply to positive 45, which is this 9 times this 5, and add to 18. So if we look at all the things that multiply to 45, we got 45 times 1, 2, 3 would work, 3 times 15, oh wait a minute, maybe I can stop. 3 times 15 multiplies to give me 45 and adds to give me 18. So I think I found my pair there. So 3 and 15 are the two numbers I'm looking for, and in the process I taught you guys, what you do is you replace 18r with 3r and 15r. And yes, I know there are lots of different other ways you can factor this, some that are a lot quicker than this method, but that involve a little bit more guessing and checking than I want people to feel like they have to do. So with this method, you won't have to guess and check. What I did is I rewrote this quadratic polynomial as 4 terms. And by choosing these 4 terms, it should factor by grouping. And so what I do now is I look at these first 2 terms, call that my first group, and look for the greatest common factor. In this case, it's r. Pull out an r, you'd be left with 5r plus 3 from your first group. This 5r plus 3 becomes your target. You want to pull something out from this second group. so that you're left with 5r plus 3. And what that something is a positive 3. If I pull out a positive 3 from these two terms, I'm left with exactly 5r plus 3, which is what I was hoping for. So I now have two terms. They both have a 5r plus 3 in them. So factor out that 5r plus 3. Now this is gone and this is gone, and all that's left behind is an r plus 3. So I get 5r plus 3 times r plus 3 equals 0. So either 5r plus 3 equals 0 or r plus 3 equals 0. So either 5r equals negative 3, in which case r equals negative 3/5, or r equals negative 3. However, if you go back up to the instructions, it says that r is some unknown number less than negative 1. This is not less than negative 1. This is more than negative 1. This must be what r is. Now that I know what r is, I can figure out what k is, because I know that k is just equal to negative 18 divided by r squared. So k is equal to negative 2. So I know that my polynomial is just f of x. Maybe I'll write this on the next page. I don't know where, down here I guess. Now I know my polynomial. It's f of x equals, and remember up here I had my polynomial, it just had k's and r's in it. Because I've solved for k and r, I know exactly what it is. It has a negative 2. And that gets multiplied by x minus 1 squared. And that gets multiplied by x minus r. But r is negative 3, so x minus negative 3 is x plus 3 squared. And then finally, times x plus 2. So the final thing I'm asked to do is graph this guy right here. This is a 5th degree polynomial. It's a 5th degree polynomial, and its leading coefficient is a negative number. And so anytime you have a 5th degree polynomial with its leading coefficient is negative, you know its end behavior. As x goes towards infinity, the y is going to go to, let's see, that would be negative infinity. You can kind of think about that as a 5th degree polynomial starts out by going up when you go to the right and down when you go to the left. But this negative leading coefficient flips things over the x-axis, so it makes it so that it goes down when you go to the right and up when you go to the left. So when I go to the left, I go up. So I have to exhibit this end behavior. I have to make sure that I go through the correct x-intercepts, and I want the y-intercept to be negative 36. How the hell am I going to do that? Okay. I'm going to change the problem. I'm going to make this negative, 9, I guess. Let's do that. This is negative 18. This is negative 27. This is negative 36. So similarly, these are 9, 18, 27, and 36. Fine. Now at least I can show it in the picture. So I had that the y-intercept was negative 36, right here. It goes through the point negative 1, negative 32, somewhere in there. It's got x-intercepts at negative 2, corresponding with this factor, negative 3, corresponding with this factor, positive 1. That's all of my x-intercepts. And I want my end behavior, I want it to go down when it goes to the right, and I want it to go up when it goes to the left, meaning it's going to start way up here and then go to this point. Note that the multiplicity of the root at negative 3 and at positive 1, those multiplicities are even. So it's going to start up here, and it's going to come down, and it's going to bounce off this point right here, come up somewhere. I don't know how high until I take calculus. It's going to go through negative 2, and go through this point and through this point. And it's going to come up and go through this point, but again bounce off because that multiplicity was even. It's going to end up going down just like the end behavior predicted. Here's a very, 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 very rough graph of what this polynomial looks like. A lot of things we don't know that we won't learn until calculus, but we do know it's going to go through all these points and kind of exhibit the behavior specified at those points and have this end behavior. So the final answer should look something, roughly speaking, like this. So I will end this long video here.